Hello, everyone, and welcome to Techie. Have you ever stopped to think about this question? Think about it. We've got billions of devices connected to the internet right now. Your phone, your laptop, your smart TV, maybe even your fridge. But the main system for internet addresses, the one we call IPv4, it only has about 4 billion unique addresses. So how does that even work? How do we not just run out? Well, the answer is actually a really clever system that uses two different kinds of IP addresses. And to really get how it all works, we've got to start by looking at the one the whole world sees. Okay, so first up is the address that your entire network shows to the rest of the world. This is kind of like your network's public face on the internet. We call it your public IP address. So what exactly is that? Well, a public IP address is basically a unique ID that your internet service provider, the company you pay for your internet, assigns to your entire network. And the keyword here is unique. It's globally unique, which means at any given moment, no one else on the entire planet has the same one as you. It's the specific address that websites and servers use to know exactly where to send data back to your network. A really great way to think about this is to imagine it's like a mailing address or a P.O. box for your whole house. All the mail coming from the outside world gets delivered to that one single address. It's public, everyone can see it, and it's how the global postal service, or in this case, the internet, knows exactly where to send those packets of data for everyone in your home. All right, so that takes care of the outside world. But what about all the different devices inside your house? Your laptop, your phone, your tablet, they all need addresses too, right? Well, that's where the second and just as important piece of this puzzle comes in, the private IP address. So a private IP address is an address that only works inside your local network, your home Wi-Fi. Your router is the one that hands these out to every single device that connects to it. Your phone gets one, your laptop gets one, your gaming console gets one. And here's the crucial part. These addresses are not unique out on the internet. So my laptop could have the exact same private IP as your laptop, and it's totally fine because they're in their own separate private networks. Think of it like the phone extensions in an office. You can dial, say, a 4-digit extension to call your coworker down the hall, right? But you can't use that same short number to call someone in a different country. It just doesn't work outside the building. And that's exactly how private IPs work. They're strictly for internal communication. Okay, so let's just quickly compare them side by side to make it super clear. When we talk about scope, public IPs are global. They work on the whole internet. Private IPs, they're just local for your home network. Then there's uniqueness. A public IP has to be one of a kind, totally unique across the entire world. But a private IP, it only needs to be unique inside your house. And finally, who hands them out? Your ISP gives you your one public address, but it's your own router that assigns all those private addresses internally. It's a really great way to see the key differences at a glance. So, we've got these two separate systems, right? A public address for the outside world and all these private addresses for our devices inside. But how do they connect? How do we bridge that gap? How does my laptop, which has a private address the internet doesn't recognize, actually get information from a website? Well, here's the problem we have to solve. By design, the big, powerful routers that run the internet are set up to just ignore or drop any traffic they see coming from a private IP address. It's like trying to mail a letter using just an office extension as the address. The Postal Service would look at it and have no idea what to do with it. So clearly, we need some kind of translator. And that translator is called NAT. It stands for Network Address Translation. And this is pretty much the magic that happens inside your router every single second. NAT is the process that takes all the different requests from all your devices, each with their own private IP, and makes them all look like they're coming from your one single shared public IP address. Just picture this setup in your mind. On one side, you've got all your devices, your laptop, your phone, your console, each with its own private IP. They're all talking to your home router. And then that router sits in the middle. On the other side, it's facing the public internet with that one single public IP address. It's basically acting as the gateway, or maybe like a receptionist, managing all the communication going in and out. Okay, let's just walk through exactly what happens. First, let's say your laptop wants to go to a website. It sends a request using its private IP. Next, your router grabs that request. It swaps out your laptop's private IP with its own public IP, and it makes a quick note of this swap in a special log called a NAT table. Then it sends the request out to the internet. After that, the website sends a response back, but it sends it to your router's public IP, the only one it knows. And here's the final crucial step. The router gets that response, checks its NAT table, and says, this response is for the laptop. It then translates the address back to your laptop's private one and sends the data directly to you, and not, say, to your roommate's phone. And all of this happens in just a few milliseconds. It's incredible. Now, I know this all might sound super technical, but this whole system with public IPs, private IPs, and NAT working together, it actually has some really huge practical benefits that affect you every single day you use the internet. For starters, let's talk about security. By hiding all of your device's private IP addresses behind that single public one, NAT basically acts like a simple firewall. It makes it way harder for someone on the internet to directly attack your specific computer. And then, of course, there's address conservation. This is the solution to the big problem we started with. It lets literally billions of devices get online by sharing a much, much smaller number of public IPs. And for all you gamers or tech enthusiasts, this system is what makes things like port forwarding possible, which is how you open up a specific path for game traffic to host a server. It also enables remote access, letting you connect to your files at home from anywhere in the world. So really, the main thing to remember is this. Every single time you're online, browsing a website, streaming a movie, playing a game, this incredibly elegant and efficient system is just working away silently in the background. It's this beautiful combination of a public face, a private internal network, and a super fast translator connecting them both, making sure all your data gets exactly where it needs to go. So if you found this explanation helpful, we'd really appreciate it if you'd hit that like button and subscribe for more deep dives into the tech that powers our world. And before you go, we've got a question for you. What part of your home network, or just the internet in general, is still kind of a mystery? Let us know down in the comments. Your question just might spark our next explainer. Thanks so much for watching.